Across the vast expanse of the Triangulum Galaxy, millions of stars are locked in a silent, spinning duet, performing a gravitational ballet that, while elegant and seemingly eternal, often ends in spectacular destruction. These are the binary star systems, pairs of stars born together, bound forever by the invisible pull of gravity. More than half of all stars in the universe, including those in Triangulum, are part of such unions. Some pairs orbit peacefully for billions of years, their paths stable and serene. Others are on a slow spiral toward catastrophe. Every binary system is unique. Some feature stars of nearly equal mass, orbiting a shared center in perfect balance. Others are unevenly matched, one large and dominant, the other smaller and subservient. But all binaries share a delicate gravitational relationship. Over time, however, stellar evolution begins to shift that balance. In systems where one star is significantly more massive than its companion, the larger star evolves much faster. It burns through its nuclear fuel quickly and swells into a red giant, its outer layers ballooning outward like a dying ember flaring for one last breath. As it expands, its surface may cross a dangerous boundary, the Roche lobe, where the gravitational pull of the companion star becomes stronger than the red giant's own. At that point, matter begins to flow from the giant to the smaller star in a process called mass transfer. This dramatic shift can change everything. The companion star begins to swell with new material. Its brightness may surge. It may erupt in nova outbursts as it struggles to absorb the sudden flood. If the system survives this phase, the red giant may eventually collapse into a white dwarf, leaving behind a dense stellar core still locked in orbit. But the drama doesn't end there. If the white dwarf continues to pull mass from its companion, it can reach a critical limit, known as the Chandrasekhar limit, and ignite in a catastrophic Type Ia supernova. These explosions are some of the brightest events in the universe and are used by astronomers as cosmic yardsticks to measure the expansion of space itself. Other binary fates are even more extreme. In some systems, both stars are massive enough to end their lives as neutron stars or even black holes. After billions of years, gravitational radiation causes their orbits to decay. They spiral inward slowly, until one day they collide. The result? A violent merger that emits a burst of gravitational waves, ripples in the very fabric of space-time, along with high-energy radiation and possibly even heavy elements like gold and platinum, forged in the fire of collision. These events, once purely theoretical, are now being observed in real time by instruments like LIGO and Virgo. In fact, one such neutron star collision was detected in 2017, producing not only gravitational waves but visible light and gamma rays, a cosmic multi-messenger event that reshaped our understanding of stellar death. Back in Triangulum, astronomers have cataloged thousands of binary systems at various stages in their life cycle. Some are just beginning their dance, two young stars glowing side by side in a cradle of gas. Others are older, with one partner already evolved, transferring mass in luminous arcs of material. A few may be in their final acts, slowly spiraling toward one another in silence, their fates sealed. What makes these stories so haunting is how intimate and destructive they are. Binary stars don't just coexist. They interact, influence, distort, and often destroy one another. Their gravitational love story is as poetic as it is perilous. In some systems, the smaller star eventually outlives its giant companion, only to find itself orbiting the dense corpse of its partner, a white dwarf, neutron star, or black hole. In rare cases, the surviving star is eventually consumed as well, falling into the abyss after millions of years. And in other systems, the stars merge entirely, forming a single, more massive and unstable star that burns with renewed fury, only to die more quickly in a supernova or collapse. These are not rare anomalies. They are fundamental parts of stellar evolution. Without binary systems, we wouldn't fully understand how stars change, how elements are formed, or how gravitational waves are generated. Every violent ending tells a deeper truth about how the universe works. Binary stars are not just systems, they are cosmic relationships. Sometimes harmonious, often volatile, always transformative. And their echoes, in the form of radiation, light, and gravity, ripple across the galaxy, reminding us that even in space, the most beautiful dances are sometimes the most tragic.